Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question in which we have to find out the change in the output voltage V naught. So the question is that a 4-bit weighted resistor digital to analog converter with inputs B3, B2, B1 and B0, which are B3 the MSB and least significant bit B0 is designed using an ideal op amp as shown below. So basically this one will act as the circuit acts as a summing amplifier and the switches are closed when the corresponding input bits are logic 1. When the input bits are logic 1, then it is automatically closed. Okay, and open otherwise. Okay, when switch are closed when inputs are logic 1. Okay, like b3 u1, then it is connected. So we have to find, so when the inputs b3 b2 b1 b0 changes from, okay, the inputs here I am writing the b3 b2 b1 and b0. Okay, so this one is value is first thing 1 1 1 0 and another one 1 1 0 1. For this one, for triple 1 0, what should be the v naught 1, we can say output voltage, and this one what should be the output voltage. Okay, and we have to find finally the difference the overall voltage we have to find. Okay, so overall voltage difference will be our v naught 1 minus v naught 2. Okay, so when the input b3 b2 b1 b0 changes from 1110 to 1101, so I am saying this one is output v naught 1 and v naught 2. So we have to find the change in the output voltage v naught in millivolt. Okay, so this one is the question we have to find. Okay, so this one is nothing but simply a summing amplifier circuit. So how it looks like summing amplifier. So if once again I am redoing the same circuit here, okay, and and if we, for the time being I am saying, if we will connect all these three, okay, B3, B2, B1 and B naught. Okay, so when we are considering, means all the B3 is our B3 is nothing but simply 1, B2 is 1, B1 is 1 and B naught is 1. So it is sorted. Okay, when it is logic high, just see here the switches are closed when the corresponding input bits are logic 1. The corresponding bits are logic 1. So for example I am saying all bits are logic 1, so it is sorted. So it is nothing but simply a summing amplifier kind of circuit, summing amplifier. So the summing amplifier output, the V naught we can write as the output voltage, just simple summing amplifier circuit minus, one can write R, this R by, okay, R plus R by 2R, okay, plus R by 4R plus R by 8R. Okay, when all are 1. Okay, now for simplification, for we can also write here B naught, sorry, B3 first you have to, this is we can write as B3, B2, B1 and B0. We can write or you can also, but when it is 1, then all are 1. Okay, 1 and 1. Okay, so we can write like this. Okay, now for the simplest example, okay, if you don't know the basic, I am just writing. Suppose two inputs are there like this. V naught and say V1, V2. And just as an example, I am saying R2 and this one is RF. So as you know, V naught equals to minus, Okay, Rf by R1 times of what? V1 plus Rf by R2 times V2, summing amplifier. Okay, and there is one more term we can write directly here into V ref into V ref. Okay, multiplication into V ref. Directly we can write because this one, once again I am writing the expression. This V naught is nothing but simply minus, okay, V ref. Okay, just like here we are saying both having same input like V ref. Okay, V ref. Okay, so it will, we can take as it is common, and then R by R by R times of B3 we can write plus RF, because the RF is R, so RF is R, the feedback resistance, so R by 2R B2, okay, plus R by 4R B1 plus R by 8R B0, okay, or is it okay? Means this expression, or simply we can write, because R is common in all, so one can write B3 plus B2 by 2 plus B1 by 4 plus B0 by 8. Okay, clear. So this one is the equation that we have developed. Okay, and this one is the simple summing amplifier that we know. Okay, and here also we have written the same expression we ref here. So now, so expression is now clear. So now the voltage changes from 1110 to 1101. Okay, when the input, okay, so the first thing, okay, for the input, okay, okay, I'm just copying this thing. Select it. Control C. Then suppose we have to find the voltages. Okay, when it is changes from this. Okay, so now we have to find the output voltage V naught. So we can say the V naught one value when 1110. Okay, so this first one is our B3, B2, B1, B0. Okay, so the modified equation minus V there, so directly we can write for this one minus V there. B3 is 1, so 1 we can write 1 plus 1 by 2 plus 1 by 4 plus 0 by 8. Okay, and minus V ref we know already it is given 2 volt. Okay, 2 volt. See here 2 volt. Okay, so directly we can write this one is our minus 2 volt. Okay, so volt no need to write 1 plus 0.5 plus 0.25. Okay, so if we calculate minus to 1.75, then it should be minus 3.5 volt. Okay, the output voltage I am saying V naught 1 when the input is this. Okay, I am writing here when 1101 is the input change. This one, see, when the input change like this. Okay, 4 is the input change. Okay, so simple summing amplifier kind of problem is that. Then again we have to do it for this one. Okay, so again for the second V naught 2 we can write for 1101. Okay, again this one is B3, B2, B1, B0. So B1 is 0 now. So what we can write minus V ref as it is we can write, then B3 1, so no need to worry. 1 by 2. V1 is 0. So 0 by 4 plus 1 by 8. Okay, and this one is minus 2 volt. So 1 plus 0.5 plus. Okay, the other thing 1 by 8, 0.125. Okay, so then if we solve minus 2 into 1.5 and 1625. Okay, so it will be minus 3.25 volt. Okay, so what we observe that for input change this, okay, the output voltage is minus 3.5 volt. This value is, okay, it can be calculated like this. Okay, just same formula we have used. Similarly for the input this, okay, we have to go for this formula. Okay, and then finally what we observe, this value. So now we have to find the difference. So in the question C, difference is needed when the magnitude of the changes in the output voltage we know. So output voltage change, okay, the magnitude of the output voltage change. So we can write here, okay, the magnitude of the output voltage change. Output voltage change we have to find. Okay, so how we will find magnitude? So I am saying this one is our V naught. Okay, so V naught we can write simply V naught 1, that is our triple 1 0, minus V naught 2, that is our 4 1101. What should be the change in the output? Okay, change in the voltage. So for this purpose we have to take the magnitude. Okay, so we are just putting in the modulus. Okay, now what we can write, this value is given minus 3.5 volt. So we can write like this, minus of 3.25 mode. This one is mode sign, so it should be minus 3.5 plus 3.25. So it is simple problem. Then it should be minus 0.25. Okay, modulus, so the value will be 0.25. Okay, so what should be the value? So 0.25. Okay, so what we can write, this 0.25 we can write like this, and if we multiply with 10 in the numerator and denominator, right, 250 into 10 to power 3 means 250 into 10 to power minus 3 means 250 millivolt. Okay, because in the question we have to write the magnitude of the output voltage change in millivolt. Okay, magnitude of the, so this is our 250 millivolt. So in the fill in the blanks, this one we have to write the value of change, that is our only 250. Okay, we have to write because they are asking in millivoltage. Okay, they are asking in the millivoltage. Clear? They are asking in the millivoltage, so directly we can write it should be 250. So this is a simple problem, but we have to know the basics like summing amplifier concept. I have taken two input, okay, V3 V4. So similarly we can write, then you can write like this expression into VRF. Here I have written directly output voltage because it is in the inverting amplifier kind. So for this one we have find the V0 1 V0 2, and then we have subtracted here, so it came 250 millivolt. Then okay, so this is all about this question. So thank you for watching this video. Thank you.